Hi, Year 12 had a couple of questions about question 6 of the binomial distribution assessment, so I thought I'd go through both parts now. So 6i I don't think that caused too many problems. It was the second part. So main thing to notice here is that it's binomially distributed because the thing's either defective or it's not. So that's success or failure. There's a set number of trials. In this case, it's 100 for part I. And then we'll go from there. So x is a random variable, or the random variable. X is the random variable of a product being defective, so not working. And we can say x is binomially distributed with 100 trials, and the probability of it being defective is 0.05 or 5%. So all that information is in the question. We want the probability that x is greater than or equal to 3 because it says that the inspector will find 3 or more defective articles. So in your calculator, your lower limit will be 3, upper 100, number of trials is 100, and probability is 0.05. And when you press execute on that, you should get 0.88173701, which is about 88.2%. Okay, part II. So there's two situations here where they will reject the samples. One is, this is where they accept the samples. So if a random sample contains fewer than 2 defective articles, or if it contains exactly 2, so basically anything more than 2, they will definitely reject. If it contains exactly 2, then they need to take another sample of 10, and then there needs to be 0 defective articles from that. So let's find the probability that they accept the batch, because that's the information that we're given here. So probability to accept is the probability that they find fewer than 2, so that's less than or equal to 1. I could have also written that as less than 2, plus, because it's an OR scenario, plus the probability that x is equal to 2, so they find exactly 2, and then after that, so it's almost like a tree diagram following it, you find 2, and then, so we're going to times it by the probability that there's none after that. So you take a sample of 10 and there's 2 defective, and then you take another sample and there's 0 defective. So that would be a multiplication situation because you're saying 2 and then finding 0. So this first probability here we can do in our calculator. Our lower limit is 0 and our upper is 1 because we're looking at all the probabilities from 0 to 1. Our number trial is 10. So I might have put that this is binomially distributed with 10 and 0.05 instead of 100 as before, so I might have just included that in my working for this. And then execute on that, and that probability is 0.913866164. So remember, this is the probability of accepting, but we actually want the probability of rejecting, so maybe I'll think about what am I going to do once I found this accepting. So then I need the probability of finding exactly 2 faulty articles. So that would be NCR times the probability of a defective one, where that happens 2 times, times the rest of them being non-defective. So that's that probability. Let's just highlight that to make that clear. That relates to that. Then times all that by the probability of finding 0, so NCR to NC0 times 0.05 to the power of none, times 0.95 to the power of 10, which really we can just, this is 1 and this is 1, so really we don't actually need that bit, it's just 0.95 to the power of 10. There's also a quick way to do it in your calculator without having to do this. You should show this as you're working, but if you go on to the usual steps, so in stats mode, then distribution binomial BPD for just a single probability, then you can put x is equal to 2, number trial is 10, and the probability is 0.05. Execute on that, that's 0.0746347 times, and then I can just do 0.95 to the power of 10. In my calculator, that's 0.5987369392. So the probability of finding 0 defective units is actually quite high, it's at 60%. Then I'm going to times those two numbers together, 463479, and I'll get 0. So this sum here equals 0.04468660573 plus this number from before, because it's that's our and or scenario. It's if we have less than 1 or less, then that's probably, then we're going to accept, or if we get exactly 2 and then exactly 0, then we're going to accept as well. So if I add those together, I get 0.958548247. I'm going to do 1, take away that answer, because the probability of rejecting must be 1 minus the probability of accepting, because they are the complete events, they are complementary of each other, they complete each other. Rejecting and accepting must be like the total, those probabilities add to 1, so it's 1 minus 0.958 blah blah blah, that number up there, and that in your calculator is 0.0414517 blah blah blah. So the probability that they reject is about 4.15%, and that's just what we did that to 3 significant figures. Right, hope that helped. If you've got any more questions, then let me know.